Alright, let's recall some concepts of calculations with exponential expressions.
On multiplication of monomial terms. Okay, let's take a look at multiplication of monomials here. Alright, now we can only add or subtract like terms as we saw when we add or subtract polynomials in the last section. But here we can multiply terms that are not alike, as you recall. So for example here, if I have something like a negative 6x times let's make it 12y, for example, then all we do is just basically write the answer down, because what we do is we multiply the numbers first, the coefficients. So negative 6 times 12 is what? Negative 72, and then x times y is going to be xy. Alright, so that's not too bad at all. But let's recall this one rule for multiplying two exponential expressions we have in mathematics here. Okay, so for example, let's say I want to multiply out x cubed times x to the 4th power. Alright, let's say I want to multiply these two monomial terms. So how do I go about doing that? Well, as you might recall, then if I have x cubed, how many x's is that? That's 3 of them, right? That's x times x times x. That's 3 x's for x cubed. For x to the 4th, it's going to be what? 4 x's. 1, 2, 3, 4. All right? So when we're multiplying two exponential expressions together, it's really counting how many x's I have in this case, how many exponents I have altogether. As you can see, I have what? 7 x's altogether. So this is going to be x to the what? X to the 7th. And as you may guess, then, all you do is to count how many exponents you have, you just add up the exponents here. Alright? So, therefore, the rule that we have, if you recall, is that x to the m power times x to the n power is equal to what? X to the m plus n. Alright? So this is the rule that you want to recall from Math 30, for example, when we're multiplying two exponential expressions. Alright? Let's try one here. Let's try this problem then. All right. Let's take a look at, for example, how about x to the 4th, y to the 7th times x squared, y cubed. So let's try this one. All right. So again, here we just add up the corresponding exponents. Now you can do this in your head again, but I'll show you one additional step here. Okay. So I'm just going to show the step of adding them up down here. So this is going to be x to the what? 4 plus 2. All right. Y to the what? 7 plus 3. So therefore the answer is going to be x to the 6th, y to the what? 10th. So again, we just jump straight to the final answer in this case, but I just show you one additional step here. Alright? Okay, so let me go and clear out this screen. Let's go and try another problem. Let's try this one. So keep this rule in mind when we're multiplying two exponential expressions, x to the m times x to the n, we add the exponents, all right? M plus n. Keep that in mind, all right? Again, multiplying two exponential expressions, you simply add the exponents, all right? Of course, it has to have the same base. If this was x to the m, this is y to the n, then we can't do anything because the bases are different. The bases have to be the same for this rule to work, all right? So let's try this one. Let's throw some numbers in. Let's look at negative 3x squared y to the 5th power, all right, times 7 x to the 9th, y to the 6th. All right. So let's go ahead and try to multiply these two expressions. Again, all you do is just multiply the numbers first. All right. So negative 3 times 7 is what? Negative 21, as you may guess. And then we have x to the 2 plus 9. So let me skip that step. Just say x to the 11th, y to the what? 5 plus 6, also 11 in this case. All right. So again, these problems are very quick on the homework here, right? These are very quick and easy problems here, all right? Now, let's take a look at, at the other rule that I want to get at here. What happens when I take a power to another power? So, for example, let's say I have something like x cubed, all right, x cubed, and I take that to the 4th power, all right? Now, what do I do now? How do I calculate this? Do I still add 3 and 4? Well, obviously, in this case, we don't, as you may recall. All right. Now, let me look at this here and show you a different way here. X cubed to the 4th, right? What does that mean? That means x cubed times x cubed. Sorry about that. Times x cubed times x cubed. All right. So we have four. Excuse me. We have 4x cubes here. Can we see that? So if I apply this previous rule here, then I'm just going to add up those 4 3s. 3 plus 3 plus 3 plus 3. All right. But then that's going to be what? That's really 3 times what? 3 times 4, isn't it? So that's why the answer is x to the what? X to the 12. So the point is, when you take a power to another power, what do? You multiply the two powers together. So in general, then we have this rule here. This other rule that you want to recall. If I take x to the m power, raise it to the n power, that's just going to be x to the what? M times n. All right. So keep that in mind as well. All right. So x to the m times n. Again, power to a power, you multiply the powers. When you multiply two exponential expressions, you want to add the powers. Okay, so know when to add them, know when to multiply them. We'll mix them together in a moment here. Let's try this one then. Let's take a look at 2. Let's take a look at 2x to the 4th raised to the 3rd power cubed. All right. So how do I handle this one? Well, this cube is being applied to both of the factors inside. It's being applied to the 2 as well as x to the 4th. So you want to break it up as such. So you want to break this up into what? 2 cubed and x to the 4th cubed. Can we see that? All right. So 2 cubed is going to be what? 2 times 2 times 2. Well, that's going to be 8. All right. And x to the 4th to the 3rd power, that's x to the what? 12. Right. 4 times 3. Okay. So again, make sure we can handle numbers as well. All right. Let's go squeeze one more in here, if you don't mind here. Let's look at negative 5 x squared y to the 4th power. All right? Negative 5 x squared y to the 4th power. So again, break that up into negative 5 to the what? 4th, x squared to the what? 4th, and y to the 4. So I need to apply the 4th power to what? All 3 factors here. The negative 5, the x squared, and the y. Can we see that? Right? Negative 5 to the 4th. That's negative 5 times negative 5 times negative 5 times negative 5. You can punch on the calculator, or there's a button on your calculator. Let me digress a little bit. There's a button on your calculator that looks something like this. It depends on your calculator here, but it'll look something like this on some calculators, or it's switched around on other calculators. It'll look something like that. All right. You also may see the caret key I mentioned on some calculators from the last section here. All right. So one of these 3 features allows you to what? To take a number to a power. All right. For example, if you want to take negative 5 to the 4th power, how do you do it? Well, you would punch in negative 5 first. Now, there's a button also for entering negative numbers. It looks something like this on your calculator, right? So to punch this in, then you would, on my calculator, for example, I would punch in 5 first, and then I would punch in the negative sign to make it negative, and then this is the button I have on my calculator right here, and then I would punch in this button here, this power button right here, all right? And then I would enter the exponent of what? Of 4, okay? And then I would hit the equal sign. In fact, some of you may not have to hit the equal sign, but in this case, let me throw that in there just in case you do need to hit it. So 5, this button makes the 5 negative, and then this raises the negative 5 to what? To the 4th power, and then it gives me the answer, right? And the answer here is going to be what? Negative number raised to an even power is what? Positive. So positive 625 is the answer we ought to get from the calculator, all right? And then that's x to the what? 2 times 4, 8. Y to the what? Now, what's the power on y? It's not written, so it's implied to be 1. 1 times 4 is 4. So our solution here is going to be 625, x to the 8th, y to the 4th. All right, can we see that? Again, know how to use this power feature on your calculator. And I can also help you more in class as well on this feature. All right? So let's go ahead and look at another problem. Let me clear out the screen. So again, keep these 2 rules in mind right here. I know when to add exponents, know when to multiply exponents. Again, power to a power, we multiply the powers. All right? Let me go and clear out the screen. Okay? Let's try this one then. let's look at negative x cubed y to the 5th power all that to the 8th power times times 3x squared y to the 9th quantity cubed. All right. Let's multiply two exponential expressions together. All right. So here's the first exponential expression. Here's the second exponential expression, and we're multiplying them together. All right. So by the order of operations, I need to what? Simplify each of them first. All right. So that means what? That means I need to take this quantity to the 8th power first, get an answer. Take this quantity to the 3rd power, get another answer, and then multiply the two answers together. Can we see that? So let's do that. So negative to the 8th. Now again, a negative number raised to an even power is what? Positive. So that will be positive. So I can just sort of take away. I think of this as -1 anyways, right? So in other words, look at this as -1 to the 8th, if you will, right? Invisible 1 right here, right? And then x cubed to the 8th, y to the 5th to the 8th. Now you can skip some of these steps and do it in your head if you want to. All right. So what do I get then? Well, again, I mentioned that's going to be positive, right? Negative number to an even power is positive. So just drop off that, right? X cubed to the 8th, that's x to the what? 24th. All right. Power to a power, you multiply the powers. Y to the 5th to the 8th, 5 times 8, 40. So y to the what? 40. Okay. So that's the answer to the first exponential expression. Let me put in parentheses because I still need to multiply to that. All right. Now let me figure this out. So that's going to be what? 3 cubed. That'll be x squared cubed, and y to the 9th cubed. So cube all three factors inside. All right. 3 cubed is what? 3 times 3 times 3. Again, I'll use the power button on your calculator. But 3 times 3 times 3. Hopefully we know it. We know it as what? 27. X to the what? X squared to the 3rd, so 2 times 3, x to the 6th. Oops, sorry about that, 27 there. Okay, so again, 3 cubed, 27. All right. So x squared to the 3rd, x to the 6th. All right. Sorry about that. That's a 6 right there. Sketchpad's giving me some grief here, so I apologize for that. And then y to the 9th to the 3rd, 9 times 3, y to the what? 27. Okay, that's a 27 there. Okay then, so let's multiply them together. So again, what's the number here? That's a 1, right? So 1 times 27 is 27. All right. X to the 24th, x to the 6th. Now we what? Now we're multiplying exponential expressions. So we just add up the exponents, right? 24 plus 6, x to the what? 30. All right. And then y to the 40 plus 27 here. So y to the what? 67, right? So we get our result. Okay, so again, here we're combining the two rules together here to get our solution here. Okay, let's try this one here. All right, let's look at this problem. Let's look at 4a squared times the quantity 2ab squared quantity cubed. All right. Minus 2a cubed times 6ab cubed quantity squared. All right, here's a challenging problem for us. All right, now we're mixing the exponents with the subtraction problem as well. All right, so how do we go about handling that? Well, let's do the order of operations once again. Right, order of operations says what? We need to do the exponents first. So take this quantity to the 3rd power first. Take that quantity to the 2nd power first. So bring this down. Bring down the 4a squared, if you will. All right, let's cube this. All right, now let's do it in our head a little bit, if you don't mind. What's 2 cubed? Well, 2 cubed is what? 2 times 2 times 2. Well, that's going to be 8. All right, a to the 3rd, well, a cubed. All right, b squared to the 3rd, b to the what? 6. All right, can we see that? Okay, this quantity cubed is what? 8a cubed, b to the 6. Minus, again, bring down the 2a cubed. All right, square this quantity here. All right, 6 squared is what? 36. All right, a squared. And b cubed squared is b to the what? B to the 6. Okay, can we see that? Again, 6ab cubed squared is what? 36a squared b to the 6. Can we see that? All right. Now what happens next? Well, before I subtract, I need to what? Multiply these quantities out. So let's multiply it out. What is 4? 4 times a is going to be what? 32. First we multiply the coefficients, right? And I have a squared, a cubed. How many a's do I have total? Well, again, add them up, right? That's going to be a to the what? 5th. And b to the 6th by itself. Alright? And then let's multiply these two together. Minus what? 2 times 36 is what? 72. Alright? Again, how many a's do I have? 3 here, 2 here. So again, 5 a's total. A to the 5th. And then b to the 6th, just bring that down. Okay? So now, are these like terms? Because we can only add or subtract two terms that are alike. And in fact, yes, they are, because they have the same variables and the same corresponding exponents, as you can see. So I can subtract 32 minus 72, which is what? Negative 40. Alright, now when we combine like terms, notice when we subtract these coefficients here, right, we do not touch the exponents. So don't think this is a to the 10th or something like that, right? So the a to the 5th stays the same, because think of it as, for example, let me go on the side here. What if I have something like 3x squared minus 2x squared, right? You wouldn't give me the answer as x to the 4th, right? 3 minus 2 is 1. But again, you wouldn't do anything with the exponents, right? You just combine the coefficients here. Okay, so likewise here. So don't touch the exponents when we're combining like terms. So this is a to the what? 5th, b to the 6th, right? And that is our final solution. Okay, so not too bad at all. But again, first we follow the order of operations. We cube this quantity, we square this quantity, we get these results. Then we multiply these two together, and these two together, we get these results. Then we combine like terms, and since they are like terms, then I can combine them. If they're not like terms, then I stop right here. Okay? So again, in this case they are, so we combine the coefficients, 32 minus 72, negative 40. We have our solution here. Okay? Let's try one more, and then I'll give you some problems to post on Blackboard here. Okay, let's just try this one there. All right, let's look at 9x cubed times 3x squared y squared, 3x squared y quantity squared, that is. Sorry about that. That's a square there. Okay, and minus 6x. Let's make it plus. Let's change this problem. Let's make it plus. So let's make it plus 6x. So let's do an addition problem here. So plus 6x times the quantity 3x cubed y quantity squared. Okay, let's try that one. All right. So again, just like the last problem, we need to square out these quantities first. So bring down the 9x cubed. So 9x cubed, bring it down. All right. And then 3 squared is going to be 9 as well. X squared squared, x to the what? 4th, y to the 2nd. Make sure we see that. All right. And then plus again, bring down the 6x. Okay. 3 squared again is going to be 9 again. Once again. All right. X cubed squared is going to be what? X to the 6th and y squared. Okay. Not too bad at all. All right. Now we multiply before we add. Right. So 9 times 9 is 81. X to the what? X to the 7. Right. 3 plus 4. Y squared. All right. Plus 6 times 9 is what? 54, all right. X again, 1x here, 6x here, so 7x is total, x to the 7th, and then y squared by itself. All right. Once again, these are like terms, as you can see clearly, so I can add the coefficients. So 81 plus 54 is what? 135, all right. So 135, x to the 7th, y to the 2nd. Again, when I combine like terms, I do not touch the exponents. It stays the same. Okay, so we have our solution here.
Now let's take a look at the topic of integer exponents and applications to finish out the section.
Or on the concepts of integer exponents. Integer exponents. And also the concept of scientific notation. Okay, so let's take a look at that, scientific notation, which we'll get more into in a moment. So I mentioned what about dividing two exponential expressions, right? So let's recall the rules that we have. Let's recall that if I multiply two exponential expressions, x to the m times x to the n, then I'm going to get what? Well, I'm going to get x to the m plus n, right? So because we add exponents. If I take a power to another power, x to the m raised to the n power That's x to the what? M times n. All right. So when we take a power to another power, we multiply the power. So we've seen that already from the previous section. All right. Now, how about when we divide two exponential expressions? So let's take a look at this problem here. Let's take a look at something like x to the fifth power divided by x to the third power, if you will. All right. So how do we handle this situation? Well, as you can see, we have what, 5 x's on top and 3 x's on the bottom. So it's still really a counting kind of problem. So 1, 2, 3, 4, and 5 on top. On the bottom, we have 3 x's, 2, and 3. As you can see, the x's will, one x on top will cancel one x on the bottom since we're dividing here. So one x, these x's drop off, these 2 x's drop off, and these 2 x's drop off. So I'm left with 1 on the bottom here, and x times x, we know there's 2. So there's 2 x's left on top since there's 2 more x's on top than on the bottom, right? So we have x squared over 1, but again, that's just x squared. Okay? So what that tells us is that since I'm canceling out the x's and I'm figuring out how many more I have on top in this situation, then this is nothing more than what? Just subtracting the exponents. Hopefully we can see that, right? 5 minus 3 is going to be what? It's going to be 2. Okay? So the last rule that we have here then will be if I have x to the m power divided by x to the n power, then that's just subtracting the exponents, x to the m minus n. All right? So taking the difference of the exponents here. Okay? Not too bad at all. Top exponent minus bottom exponent. All right? So if I give you a problem like this, for example, x to the 19, y to the 8th, divided by x to the 11th, and y to the 5th. All right? Well, all you do is what? Subtract the corresponding exponents. So again, all you do is look at a problem like this and just write the answer down. So this is x to the what? 19 minus 11, so that's x to the 8th, and y to the what? 8 minus 5, so y cubed. So x to the 8th, y cubed. Okay? So again, not too bad at all. Now, but I want to get into what happens, though, when the exponent on top is the same as the exponent on the bottom. So let me go and clear this out. Let me clear off the screen here. Okay, so let me just rewrite the rule again. X to the m over x to the n is equal to x to the m minus n. All right, let's see what happens if the powers are the same here. So, for example, let's consider this case here. X to the 5th power divided by x to the 5th power. All right. Now, if I use this rule on top, all right, if I use this rule on top, then I'm going to take x to the what? 5 minus 5, right? And that will give me x to the 0 power. Okay, can we see that? Just subtracting top exponent minus bottom exponent by the rule here. By the way, one thing I forgot to mention for this rule is that since we're dividing by x to the n, of course, x is not equal to 0 here. We're assuming x is a non-zero number. All right? So let's go ahead and look at it. So x to the 5th over x to the 5th, 5 minus 5, right? Subtracting the exponents, we get x to the 0 power. Now let me also do it differently, because you may also observe that x to the 5th divided by x to the 5th, well, that means what? It's the same quantity. It's the same quantity divided by itself. So if any number divided by itself is going to cancel out, right? So I just have what? 1 left over. Okay? So I perform the same calculation here. That is x to the 5th divided by itself, using 2 different ways, right? First technique, I used the formula here, used the rule here for subtracting exponents, and I got x to the 0. Second way, I did not use the rule directly, at least. I canceled them out. X to the 5th cancels with itself, so I have 1 left over as the answer. So the conclusion, hopefully you can see from this, is that x to the 0 power is equal to what? 1. Okay? Okay, can we see that? Conclusion is x to the 0 power is equal to 1. So in other words, if you take a non-zero number, raise it to the 0 power, then it's going to be equal to 1. Okay? So what that means is, if I give you a problem such as, what is negative 17 to the 0 power? Well, that's just 1. Okay? If I give you a quantity here, what is, for example, what is a to the 4th, b to the 7th raised to the 0 power? Again, anything raised to the 0 power, any quantity taken to the 0 power is always equal to what? 1. Okay? Again, we're assuming a and b are non-zero numbers. Right? But what about this one here? How about 4x to the 0 power in this case, all right? Well, in this problem here, the 0 power is only being applied to the what? To the x. It is not being applied to the 4. If I have parentheses around the 4x, then yes, it would be applied to the entire quantity and the answer would be 1. But in this case, the 4 stays by itself, but x to the 0 we know is 1, so the answer is actually 4 times 1, which is 4. Okay, so be careful of these types of problems if I happen to sneak one up on you on the quiz or the exam here, right? So, but hopefully we can see the logic here. Again, a non-zero number raised to the 0 power is equal to 1. All right, let's examine this. Excuse me. This rule a little further, if you will. All right, what happens if the power on the bottom is bigger than the power on top? Let me give you an example of that. Suppose I have x cubed over x to the 5th power, all right? Well, so the power on the bottom is bigger than the power on top. Now, if I use the rule to calculate this, then it's going to be x to the what? 3 minus 5, right? And 3 minus 5 is what? Negative 2. So this is equal to x to the what? Negative 2. Can we see that? All right. So I get what? I get a negative exponent here. All right. Now, let's see how we can interpret that one. What is a negative exponent anyways? All right. What does it mean in terms of the calculation? Well, let's see. Let me go and recalculate this problem here. Let me copy it again. X cubed over x to the 5th. All right. Again, I have 3 x's on top, 5 on the bottom. So imagine if I write out 3 x's on top and 5 x's on the bottom. I'm not going to do it here, but you can see that x cubed will cancel with x to the 5th. The 3 x's on top will cancel out completely, so I have 1 left over. But there will be 2 more x's extra on the bottom. There will be x squared left over. Can we see that? All right. So therefore, this is equal to 1 over x squared. All right. Now, again, I did the calculation. Same problem here. I did it 2 different ways. First way, I used the rule to subtract the exponents. I got a negative exponent, negative 2, namely. Second way, I didn't use the rule directly. I used it indirectly by canceling here. So I got 1 over x squared. All right. Now the conclusion, once again, like we did over here, we did two calculations, got 2 different results. The conclusion is that these 2 results have to be the same. Likewise here. So conclusion again is that x to the negative 2 power must be equal to what? 1 over x squared. All right. Then what can we say about negative exponents? Well, we can say that to convert a negative exponent to a positive exponent, we simply bump it down to the what? To the denominator. Okay. Or actually, think of this as x to the negative 2 over 1, if you will. So to convert the negative exponent again to the positive exponent, you just simply what? Bump it down to the denominator, okay? And then it becomes positive. All right? So here's what we're saying here. Here's an extra rule we have for negative exponent, interpretation of that. Right? So if I have x to the negative n power, all right, that's going to be interpreted then as 1 over x to the n. So again, once we bump it down, the negative sign is gone. Okay? So this is the interpretation of negative exponents here. All right. Now, what's the problem? What's an application problem of that? Well, suppose I want you to evaluate something like this. What is 4 to the negative 2 power? All right. 4 to the negative 2. Okay? The answer is not negative now, so be careful here. Right. That's an exponent now. All right. I need to use this interpretation. So we have to convert all negative exponents to what? To positive exponents by what? By bumping it down to the bottom in this case. All right. So that means what? 4 to the negative 2 is going to be what? 1 over 4 to the positive 2. Can we see that? All right. Again, once I bump it down, it becomes positive. The exponent I'm talking about. Well, that's just 1 over what then? What's 4 squared? Well, that's 16, right? So 1/16 is the answer. Okay, let's try another one, and I'm going to clear out the screen. Let's work with integer exponents, namely negative exponents in particular. All right. All right. Let's try this one here. Let's look at how about 5 to the negative 33rd power. All right. Well, that's going to be 1 over 5 cubed. Again, always convert all negative exponents to what? Positive exponents by bumping it down. Then it becomes positive. So what's 5 cubed? Well, that's 5 times 5 times 5 if you Recall that, right? For exponents, right? 5 times 5 times 5, that's 125. This is 1 over 125 here. Okay, so can we see that? Hopefully we can interpret negative exponents correctly. Let's try this problem here. Let's look at x to the 8th, y to the 9th, divided by x to the 11th, and y to the let's make it y to the 6th here, if you will. All right. So I'm going to subtract exponents, right? So that's going to give me what? X to the 8 minus 11. All right. Can we see that? Top exponent minus bottom exponent, and y to the what? 9 minus 6. All right. So what will that give me then? Well, that will give me what? X to the 8 minus 11 is what? Negative 3, and y to the 9 minus 6, positive 3. All right. Now again, we always write our final answer without any negative exponents. So that means what? That means that this x to the negative 3, it has to be bumped down. So the final answer will be what? Y cubed. So y cubed, the y cubed stays on top because it's not negative. The exponent here is not negative, so we do not bump this down. It stays on top. But we have to bump down the x to the third here. So x to the third power, positive now. After I bump it down, it becomes positive. Right? Can we see that? So that's our solution here. Y cubed over x cubed. All right. Let's try another one. Let's write this problem without negative exponents here. Let's look at w to the negative 2, x to the 4th power, and y to the negative 7th power. All right. All right. Then let's simplify that. So in this situation, what gets bumped down? What stays on top? Well, hopefully we can clearly see that the negative exponents will have to be bumped down. In other words, the w and the y has to be bumped down. But the x to the 4th will stay on top. So therefore, I'm going to get x to the 4th over w squared, because the w gets bumped down because it has a negative exponent. Likewise for the y, it has a negative exponent, it gets bumped down. So y to the what? Positive 7. Again, after you bump it down, the exponent becomes what? Positive. So hopefully we can interpret negative exponents correctly here. All right, let's try another problem here. All right, so we're working with negative exponents here. Let's try this one. Let's look at 2x squared y cubed, all that to the negative 3rd power. All right, let's interpret that statement here. All right, so I need to apply what? The negative 3rd power to what? These 3 factors inside. I need to apply to the 2, the x squared, and the y cubed. All right, so this is going to be what? This is going to be 2 to the negative 3, x to the square to the negative 3, and y cubed to the negative 3. Can we see that? And 2 to the negative 3 is what? 1 over 2 cubed. I'm going to bump it down and make it positive. All right? And that's x to the 2 to the negative 3. So again, power to a power. What do we do? We multiply powers, right? That's x to the negative 6. Y to the what? 3 times negative 3, negative 9. All right? What's 2 cubed? 2 times 2 times 2. That's 8. So this is 1/8 x to the negative 6, y to the negative 9. All right? And again, x and y are both negative exponents here, so we have to bump them down. So final answer is going to be 1 over 8 stays on the bottom here, right? Don't put the 8 on top. 8 is the denominator here, right? 8 x to the what? Positive 6, y to the positive 9. Okay, so that's our final solution. Okay, so hopefully that's not going to be too bad for us. Okay, let's try another problem here. Let's look at this one. Let me go and clear off the screen here. Okay. Let's look at this exercise here. Let's look at this example here. Negative 3 x to the 4th power, y to the negative 5th power. That's a 5 there. Oh, darn it. Sorry about that. Let me go and try it again. Let me clear out the screen. Let's try it again. Sorry about that. The sketchpad's acting up on me once again, so sorry for the technology problem here. Negative 3 x to the 4th power, y to the negative 5th power. All right, that's much better. All right, times negative 2 x to the negative 3rd power, and y to the negative 1 power. Okay, so let's multiply these two exponential expressions. Again, again, what do I do when I multiply exponential expressions? Remember, we have to add exponents, right? When you multiply two exponential expressions, you have to add exponents. And no exception here, even though the exponents are negative. We still do that, all right? But first, we multiply the numbers first, right? The coefficients. So negative 3 times negative 2 is what? Positive 6, all right? Hopefully we can see that. And that's x to the what? 4 plus negative 3, all right? And then y to the what? Negative 5 plus negative 1, all right? Again, we're just adding exponents here, no big deal. That's 4 plus negative 3, negative 5 plus negative 1, all right? Let's simplify that. So that's going to be 6x to the first power, 4 minus 3 essentially, right? That's x to the first power. I'll leave off the 1 here, all right? And y to the what? Negative 6, all right? So what gets bumped down here, if you will? Well, the y gets bumped down because it has a negative exponent. The 6x stays on top. So final answer will be 6x on top, y to the 6 on the bottom. Again, always write your final answer without any negative exponents as I'm doing here. Okay, so convert all negative exponents to what? Positive exponents, okay, in your final answer. All right? Let's try another one here. Let's try another one. Let's try this one. Let's look at 3a times 4a to the negative 5th power, all that to the negative 2nd power. Okay, so a little bit more challenging here. All right? Well, it's not too much more challenging. I just have to, what? Take this to the negative 2 power first before I work with the 3a. So 3a should be brought down. Okay? So just bring down the 3a, all right? Let's work with this here, all right? So this is what? Let me do it on the side, in fact. In fact, let me work that on the side. So that's going to be 4 to the negative 2. I need to apply the 4 to the negative 2. And also the a to the negative 5th power also applies to the negative 2 power. So again, I need to apply the negative 2 power to both the 4 and the a to the negative 5th. Both of these factors will have to be taken to the negative 2nd power. Can we see that? All right. 4 to the negative 2, well, we did it earlier, didn't we? Right? That's 1 over 4 squared, which is what? Which is 1 over 16. Right? So we did that earlier. Right? A to the negative 5 times negative 2, so that's going to be a to the what? A to the positive 10, actually. All right? So this is really what? 1 over 16 a to the 10th, or simply a to the 10th over what? 16, if you will, or 1 times a to the 10th is itself. All right? So 3a, so this problem boils down to what? 3a times a to the 10th over what? Over 16. Okay? So 3 times 1, now this is invisible 1, right? 1 over 16. So this is 3 over 16. Can we see that? This is 3 over 16. And then a times a to the 10th, that's a to the what? A to the 11th. All right? So the final answer is 3/16 a to the 11th, or I can write the final answer as 3a to the 11th. So because a to the 11th is really on top, think of this as a to the 11th over 1, right? So 3a to the 11th over 16. So either answer is fine, but you see our result here. Okay? I'll just write this one down. Okay? All right, let's go ahead and try one with a division. Let me go and clear out the screen here. Okay, let's try this problem. Let's look at 4x to the negative 1, y to the 7th, all over 6 to the negative 1, all right, and x cubed, and y to the negative 2nd power. Okay, let's go and try this one. This one's a little challenging here, right? Because of the 6 to the negative 1. Look at that. All right? So, what is 6 to the negative 1 anyways, right? So let me start by working with the numbers here, okay? So I cannot cancel 4 and 6. Well, this is 6 to the negative 1. This is not just 6. So be careful there, all right? So, let's look at that. 6 to the negative 1, that's what? That's 1 over 6, right? Again, bump it down, make it positive 6. This is 6 to the first power, right? I left off the first power here, right? So 6 to the negative 1 is actually what? 1/6, all right? So this problem, if you will, boils down to 4x to the negative 1, y to the 7th, over 1/6, x cubed, y to the negative 2. All right? Let me start simplifying the numbers first. I'll work with the exponents in a little bit. All right? What is 4 over 1/6? Well, isn't that 4 divided by 1/6? Yeah, that is, right? 4 over 1/6 is 4 divided by 1/6. So 4 divided by 1/6. Let me figure it out. Well, that's just 4 times 6 over 1, right? Or just 6. So the answer is 24. Can we see that? So 4 divided by 1/6 is 24 is what I'm trying to say. All right. So therefore, I'm going to get what? I'm going to get 24. All right, for my number, and then let me subtract these exponents. All right. So x to the negative 1. Okay. Why subtracting? Because we're dividing. Okay. When we divide two exponential expressions, we have to subtract the exponents. Top exponent minus bottom exponent. So x to the negative 1 minus what? Minus 3. Y to the 7th minus what? Minus negative 2. So be careful with that negative exponent on the bottom there. Right? Minus it in parentheses. Okay. All right, let's go ahead and simplify those calculations. So that'll be 24, x to the negative what? Negative 4 here, negative 1 minus 3, and y to the 7 plus 2 essentially, so y to the 9th. All right? So what gets bumped down? Well, the 24 stays on top, the y to the 9th stays on top, but the x gets bumped down because it has a what? It has a negative exponent. So final solution will be what? Would be 24, y to the 9th on top, over x to the 4th on the bottom. So x gets bumped down because it has a negative exponent. So that's our final solution here. Okay? So hopefully we can see the concepts of integer exponents. These are problems that can be time consuming. They're a little bit more challenging than the problems that we've seen up to this point here. All right? Let's go ahead and work with the application of of these integer exponents. One application of integer exponents is scientific notation. Let's look at a number in scientific notation. Let me go and clear out the screen here. All right. Let's look at concepts of scientific notation. Sorry, the sketch pad is acting funny tonight. So, okay. So scientific notation here. All right. What is a number in scientific notation, and when is scientific notation used? Well, we use scientific notation when we have to express very small numbers or very large numbers. Let me give you an example of that. Let me give you a couple of numbers here. All right. Let's say I have a huge number such as 876,200,000, all right? That's 876,200,000, right? That's a huge number. It's very clumsy to write because of all these zeros here, all right? So that's why you want to use scientific notation to express this very large number. Or you may have a very small number, such as 0.00719, for example, all right? So that's a very small number, right? 0.00719. This is practically zero here, right? This is almost zero here, right? That's a very small number here. So again, because of these zeros here, it's very clumsy to write. Actually, this one isn't too bad. I throw more zeros in, it becomes more clumsy. It becomes clumsier, all right? So let's go ahead and look at how to write these two numbers, though, in the scientific notation. All right. Now, before we do that, though, let's look at the format for scientific notation. Let's recall what that is, because we saw a little bit of that back in Math30, for example. Right? The format is going to be some number a times 10 to some power n. All right. Now, what's a and what's n then? Well, n is the integer, is an integer exponent. All right. A is a number between 1 and 10. So 1, let me write it this way. 1 less than or equal to a less than 10. So what this means is that a is between 1 and 10, and a can be as low as what? It can be as low as 1, but it must always be strictly less than 10. For example, can a be 9.99? Yes, it can, because 9.99 is still less than 10. Can we see that? So again, a has to be strictly less than 10, though a cannot be 10. A can be as low as 1. All right. So let me give you some examples then, in light of that. All right. Here's some examples of numbers in scientific notation here. All right. So for example, something like 4.21 times 10 to the 18th. All right. Again, 4.21 is between 1 and 10, and my n is what? 18 in this case. All right. Now, is this a big number or a small number? You may wonder. Well, if n is positive, then it's a big number. It's a huge number. This is a huge number right here. This might be the distance from Earth to another galaxy or something like that. Right? I'm just throwing something out there. Right? That's a huge number, right? If we're talking about light years, for example, or something. All right. So again, that's a huge number here. If n is positive, it's a huge number. Okay. So let me say integer exponent. Let me say that when n is positive, means number is big. Number is big. All right. What about this number then? How about 2.436 times 10 to the negative 11? All right. Now when n, so here n is what? N is negative 11. So n is a negative integer. So, and in this case then, is this number a big number? In this case, no, it's not a big number. So when n is negative, then it's a very small number. So n is negative implies number is small. Number is small. Practically 0. This number here is practically 0 here, right? It's very small. This number here is a huge number here, all right? Because what this means is 10 to the 18th means what? Means that 4.21, to write this number out, I need to move this decimal 18 times to what? To the right. Here, this number is very small because of the negative integer here on the base 10. That means I need to move this decimal here not 11 times to the right, but 11 times to the what? To the left. Okay, so that makes it practically 0 here. All right. So let's go back and up here and write these two numbers in scientific notation. Recall how we can do that, right? So the key is what? The key is to get the first number to be between what? 1 and 10, right? These two numbers are between 1 and 10. So we start moving the decimal point until we get a number between 1 and 10. For example, here is my decimal right here, since this is the whole number, right? Let's move it to the what? To the left, so I get a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7. Do I stop at 7 here? Well, no, I don't. If I stop right here, then I get 87.62. But 87.62 is not between 1 and 10. So I need to keep going. Again, I keep going until I get a number between 1 and 10. That's really the bottom line here. So 8. I need to move it 8 places here. Right? 8 places. Now I get 8.762. All right? 8.762. Is that between 1 and 10? If I move it here, yes, that is between 1 and 10. So now I'm good. And it's going to be what? Times 10 to what power then? Well, since this is a huge number, n is going to be what? N is going to be what? Positive. Okay, so 10 to the positive 8. All right? Make sure we see that now. All right? Here, that's a very small number, so n is going to be negative. So let's move it, again, this time I move it to the what? To the right, the decimal point, because I'm trying to get a number between 1 and 10. Here's my decimal. Let's move it to the right to make that happen. 1, 2, 3. Stop at 3 because that's what? That's 7.19. If I move it one more over, I get 71.9. That's not between 1 and 10. Again, you always move the decimal until you get a number between 1 and 10, bottom line. So I moved it 3 places, right? 1, 2, and 3. So this is times what? 10 to the what? Negative 3 because it's a small number. So small number, n is what? N is negative. Keep that in mind. I think that's easier to remember than say if I move the decimal to the left, n is going to be positive. If I move it to the right, n is going to be negative. That'll work as well, but I think it's better if you look at the number to begin with and say, okay, that's a big number, so therefore n will be positive. That's a small number, therefore n will be what? Negative. I think that works out better for us. Okay. So again, we move the decimal until we get a number between 1 and 10. And then we count how many places we moved it to convert it to scientific notation. Okay, so let's recall that from Math 30. Again, we've done this already from a previous math class. But let's look at how to multiply numbers out and divide numbers out in scientific notation. Let me go and clear out the screen here. Okay. Suppose I give you two numbers in scientific notation to multiply out. Right? Let's say I want you to multiply out something like this here, for example. Right? Let's say I want you to multiply out 2.4, for example, 2.4 times 10 to the negative 9, all right, and multiply that with 1.6 times 10 to the third power. Okay, let's multiply these two numbers in scientific notation now. All right, how do I go about doing that? Well, a couple of things, a couple of ways I can do it. I'll show how to do it in class with a calculator. So the first way is with a calculator. The button you need on the calculator, if you want to punch it into a calculator, is the button EE on some calculators. This is on TI calculators, for example, and the button on my Casio calculator will be EXP. That's the button I'll use for scientific notation. So you may want, okay, so how do I enter this number in scientific notation on the calculator? Again, I'll talk more about this in class, but just real briefly here. So I will punch in 2.4 on my calculator, all right? And then on my calculator, I have a Casio, it's EXP. So I'll punch in EXP. And then I will punch in the exponent 9. But again, 9 is what? Negative, right? So on my calculator, I have to hit 9 first. It depends on your calculator. Then I hit, to make it negative, the 9, I need to hit the plus minus button here on my calculator. So it depends on your calculator here, right? But that's how I would enter this number in scientific notation on my calculator. Okay. So again, I can help you out visually in class here on using this calculator, using your calculator to perform scientific notation calculations. All right. So let's go and do it by hand somewhat though. Okay. If I'm doing this by hand, partially by calculator, here's how I will work it. All right. So I'm multiplying these two numbers in scientific notation. So there's 4 numbers to multiply here. Keep that in mind, right? 1, 2, 3, 4. 4 different numbers here, right? So the first thing I'm going to do is I'm going to multiply my a's. Multiply the 2.4 times what? The 1.6 first. Multiply the non-exponential numbers first. That's the 2.4 and the 1.6. All right, so let's go and do that. So let me punch that into my calculator here, if you will. So give me a second on that. 2.4 times 1.6 is 3.84. So I get 3.84 on my calculator. 3.84, all right? Now, how do I multiply 10 to the negative 9 times 10 to the third? Well, that's just what? Adding exponents, right? When you're multiplying two exponential expressions, you simply what? Add exponents. So that's just going to be 10 to the negative 9 plus 3, okay? Sorry, my sketchpad is acting up again, so this is negative 9 plus 3, all right? So then I'm going to get 3 point, okay, so hang on a second, my sketchpad is acting up again, so I need to fix that. Again, I apologize for the technical difficulties here. So I get 3.84 times 10 to the negative 9 plus 3. Because we're multiplying two exponential expressions, we're going to what? Add exponents. All right. So final answer will be what? 3.84 times 10 to the what? Negative 6 as our solution. And hopefully when you punch on the calculator, you get the same result as I got here, doing it partially by calculator, partially by hand. All right, so this is really not too bad. Again, we multiply the non-exponential numbers first, 2.4 times 1.6, 3.84, and then we add exponents to multiply these two together. All right, let's look at division here. Let's finish off with division here. So division is not going to be too bad either. Let's look at 5.4 times 10 to the negative 7 over let's make it 1.8 times 10 to the negative 16. All right, for example. All right. So again, just like we did up here for multiplication, for division, we're going to divide 5.4 and 1.8 first. We're going to divide these non-exponential numbers first. All right. So what is 5.4 divided by 1.8 in your calculator? All right. Well, hopefully you got 3. So that's going to be 3 times 10 to the, well, how do I divide two exponential expressions? Well, we now, instead of here we multiply, so we add exponents, right? Here we're going to what? Subtract exponents. So 10 to the negative 7 minus negative 16. Can we see that? So then that'll give us what? That'll give us 3 times 10 to the negative 7 plus 16, right? Which is going to be 3 times 10 to the what? To the 9th. All right, if you will. Okay, so again, and that's basically what that's 3 billion if you write this out in terms of the actual number, right? So 3 times 10 to the 9th here, negative 7 plus 16 as our solution. Right. So for division, you divide the non-exponential numbers first, then you subtract exponents here on the exponential expressions. For multiplication, you multiply the non-exponential numbers first, then you what? Add exponents here on the exponential numbers. Correct? So we're basically following the rules of our exponential calculations here. All right. Let me give you some problems to post on Blackboard here before we finish off here. Let me go and clear out the screen here. All right. Let's go ahead and post some of these problems here, if you will, on Blackboard here. So one, I want you to figure out what is 8 to the negative 2 power. All right. Not too bad. Number 2, I want you to multiply the following here. 3, all right, 3xy to the negative 2 times the quantity 2, x to the negative 1, y, all that to the negative 3rd power. Okay, so take your time to simplify. This one's a little more challenging here, all right. And number 3, let's go and divide two numbers in scientific in scientific notation, if you will. So let's take 6 times 10 to the negative 5 divided by let's make this 2.5 times 10 to the 8th here. Okay, so go ahead and post your answers in the discussion area on Blackboard, and then we can talk about these problems in class. All right, so until next time.